A demonstration with a piece of paper. You can put it through, and I think my levitator is a success. It works very good. I can push things a lot, and it also has indication of compensation fields. Actually, the potential well is amazingly deep. It can levitate 50 grams, not 150 as promised. It's barely able to levitate Snickers 50 grams. I have put a jumper sensor to ground to enable operation, and then I put a sensor simulator on sensor input pins, and 4 diodes with resistors on the transistor output. What is interesting is that here ground is not ground, it is floating. It is from this 431 reference, and it is made to eliminate spikes which are on the physical ground, which drives the coils. Here we see that there is a slope changing, and here also going up. It's kind of integrator. It is 220 microfarad capacitor and large resistor action. Me achieving levitation for the first time, stable, and I have LEDs on coil channels, LEDs on sensor. They are useless, and the current is 0.4 amps when it's levitated and both LEDs are off. When LEDs are on, we have above 1 amp, and then coils get hot and transistors get hot. Sensors were too high, then we got oscillation. It was too much gain in the feedback loop, so they have to be 2 or 3 millimeters below the coils. The screws were slightly too long and were touching the operational amplifier, so I put 2 washers. Center wire of the coil goes to pins labeled with number 1. And then same on this coil. Here it goes to pin labeled 1, but these 1 and 2, they have changed the place compared to other side. You can see that I made a big mistake in the beginning, soldering transistors opposite. But I could bend the transistors and break them out and then solder back correctly. And I have soldered 2 resistors incorrectly. Then I had the circuit not working, so I soldered again as the correct values. And I have put LED at each transistor pair output. I could not get the circuit working with floating ground of TL431, so I put 5 volts from 7805 regulator to here and grounded these capacitors, so that makes 5 volt reference for operational amplifiers. I had big problem assembling the board because the resistors, they had no value markings under them. So don't buy such board where is no markings of resistor values. You will get a big trouble to find out resistor values from other boards. The trimmer screws are used to center the magnet. And I am very happy with the current. It is 0.2 amps at 12 volts. But if the magnet moves to the side, we can get above 1 amp. Here is the mode where magnet oscillates, and oscillation is supported by the circuit. Trimming the potentiometers got current consumption down to 0.1 amp. If we disconnect power, then we have gone. This is very important about the polarity of the magnets. The permanent magnets should attract to the center piece. With disconnected power, we need attraction from opposite side to the coil magnets. So these are also 4 coil magnets with iron core, and they have been magnetized. And then without external power supply, you should get repulsive force from the coils and attractive from the permanent magnets. Then it's aligned correctly. Now I want to see how long this magnet rotates. Should be very low friction. After 8 minutes, can start to see irregularity. 9.5 minutes. So basically 10 minutes spinning. Now it starts to spin backwards. And backwards it spins forever. Apparently it gets energy from the circuit. Some micro oscillations. The small magnet on the bottom is very important. It makes the potential well more narrow. Here is another try with 2 small magnets. The potential well is quite deep. I can bend it and it will come back. Since I bridged 5 volts from regulator to the circuit, I have blue LED always on, but when magnet approaches, then it becomes much brighter. I can put more magnets, but the circuit oscillates. It's too much gain in the loop. In this configuration also get oscillation. The height is about 2 centimeters. Now I will change power supply voltage, 14 volts, and Yeah, it's moving sideways, not up and down. And at 10 volts it will crash. 11 volts, 10.6, 10.5, 10 volts. My colleague bought such a kit from AliExpress and it had good instructions how to assemble. So he assembled it and it works. And the box protects the circuit from crash. Another colleague bought such kit and it's different from mine kit. Slightly different placement of the parts. This kit with 8 magnets can hold 100 grams. Here it levitates 50 grams, and if the mass is very high, then it's harder to get stability. The colleague wanted to make a rotating magnetic field to rotate magnetic steerer for use in research to steer cells in a glass beaker without touching walls with magnetic steerer because it crashes the cells. Also large objects can spin. Need to be balanced, center of mass. Kitty cat, 40 grams. Works okay. Magnet diameter 25 millimeters, 1 inch, 15 millimeters. Adding more small magnets make it possible to tilt without falling down. I can reproduce image from somewhere in internet that it is possible to tilt levitator and the thing does not fall down. Notice that upon tilting, compensation coil starts to work. Also, the board can be moved on the table quite. In this levitator, the components are put on this side of circuit board, which is nice to troubleshoot with oscilloscope, but still hard if you are levitating something to put a probe from below. A marker. A pencil which spins forever. It likes to climb a hill and then fall down in a valley and get kicked from electronic somehow feedback. Easiest to levitate objects which are not tall, that the center of mass does not fall outside the returning force region. Seems possible to get motor action by applying phase shifted current to the coils. Here is Arduino PWM in action, and we have magnet in water. We can make such movement up and down, but not rotating now with standard magnet. A very simple program which creates two sine waves with 90 degrees offset for rotating field, and the variable delay read from potentiometer. But now adding extra magnet, creating asymmetry, we can induce rotation. It's quite wobbly, so probably field strength is still too high. And can make it faster. But with two phases, looks like it will not self-start. It needs a kick to rotate. Motor action in air using Arduino. Trying to move slowly. Part from Kinder spins forever.